Hello everyone, today I'll review the Creality K1C 3D printer. K1 was indeed one of the 3D printer models that quickly entered the market recently. Initially, it encountered some problems like the hot end, extruder, but Creality swiftly fixed them in a very short time span. It then proceeded with the K1 Max model, which notably has a larger printing area. And, as with almost every model, Creality, who I genuinely believe values user feedback significantly, made some notable improvements on the K1 and subsequently launched K1C in the market. In this video, sponsored by Creality, I'll review the K1 model 3D printer and share my impressions with you. Let's briefly examine the printer's features, then we'll proceed to review with test printings. In terms of design, the dimensions of the K1C, very similar to the previous model K1, are nearly the same as the previous version. Its width and depth are 35.5 and its height is 48.2 centimeters. This small height difference is probably due to the feet underneath. These feet are wider and softer than previous models. The aim with these new feet is to better absorb the printer's vibration. The top cover of the printer, fully closed, is acrylic, while the front cover is tempered glass. In the previous model, the front glass, which didn't stay still during fast printing, can now stay fixed with a small hinge intervention. There's no change on the screen. The 4.3-inch color touchscreen is quite clear, high resolution, and the touch sensitivity is very successful. The simple and easy-to-use interface we are used to in the K1 series continues in the same way. We can control the printer with wireless connection feature through Creality Print. We can send the model we didn't mention remotely, intervene in settings such as speed, fan, temperature during printing, or observe the printing with its internal camera, or shoot accelerated videos. We are not dependent on the computer for tracking. We can use our printer in the same way via the Creality Cloud application on a tablet or phone. This camera also has an artificial intelligence. If the model separates from the plate during printing or encounters a problem called spaghetti, the camera detects this, and the printer warns you by stopping the printing. The interior design of the K1C is compact, as in previous models. The thick front panel is the first thing you see when you open the lid. This won't have an extra effect on its durability, but it's clear that its appearance has improved. A magnetic flexible build plate has been used on it, just like in previous models. However, as a small detail, an apparatus has been integrated into the back part to clean the nozzle tip before printing. As you will notice from the text on the front panel, the printing area of the K1C is 220 mm in depth, while the maximum printing height is 250 mm. This build plate performs its movements on the Z-axis at the middle point at the back, and on the right and left sides at the front, on a trapezoidal screw shaft and steel shaft. There is a motor in the back on the Z-axis. The power is sent to the front shafts through belts. The movements in the X and Y axis of the printer, which has a core XY system, also take place on steel shafts. Leveling is fully automatic. With pressure-sensitive sensors under the bed, the nozzle touches many points and adjusts its height. An important change in the printer has also occurred in the hot end system. Now, a nozzle called Unicorn by Creality is installed in the hot end. While the body of this nozzle is copper, the tip is hardened steel and the barrel part is titanium alloy. The purpose of developing this system is to ensure that carbon-added filaments can be printed comfortably without causing any wear in the nozzle. Not the only claim of Creality. According to their data, the system can be used smoothly for over 1,000 hours. No speed increase in K1C compared to previous models. Still a printer with speed of 600 mm per second, acceleration of 20,000 square millimeter. It also includes a vibration sensor to reduce the effects of vibration at this speed. Creality, knowing the importance of cooling in printings taken at these speeds, has kept the system in models like K1 and K1 Max. There is one fan in the head for cooling, while the giant auxiliary fan is positioned on the side of the printer. On the back, there is a case ventilation fan which is integrated with a carbon filter. As you can see, while K1C is quite similar to K1, Creality has made some small touches that could make our use more practical. Additionally, they have created a system that enables us to utilize carbon-infused filaments. Presently, we will observe the outcomes that this device produces when used with materials such as PLA, ABS, ASA, and TPU. We will both evaluate its performance at high speeds again and examine the results with carbon fiber reinforced filaments. Now let's start reviewing with standard test models. First, I took the printing of 3 test models with settings already available in the printer memory. Since all of them were quick printings, I directly used Creality's Hyper PLA developed for speed. The Benchy Boat model was printed in 16 minutes. Printing time for this model is decreasing on fast Creality printers. We started with 25-26 minutes, it became 22, then 18, now it has dropped to 16 minutes. I actually really noticed tiny lines on it, but apart from that, there's no sagging or stringing. Pretty good for a test model which is printed in approximately 16 minutes. This is a filament holder designed to easily integrate on the printer. You can attach it next to the printer. Some users don't like the filament being at the back. They prefer not to because it requires a space at the back of the printer and because they can't see the filament. This has turned out to be a nice solution. The printing is quite nice. There is a small amount of nozzle at some upper points. Apart from that, I don't see any problem in printing. And the speed test print is a model where we can see the maximum speed of the device in single surface mode without interruption. No problem on the printing taken at a speed of 600 millimeters per second with an acceleration of 20,000 millimeters per second squared. When you use filaments specially produced for high flow speeds such as Creality Hyper, it becomes easier to get good results in your fast prints. I recommend it especially for your fast printing. We continue with PLA. The printing was taken with the standard settings of the Creality print slicing software. I did not modify the settings. I will demonstrate these settings that fluctuate between 200 and 300 millimeters per second. This is an incense burner. Some say, you make many burners? You're right, but I download models from Stlflix. They make very beautiful models. Well, I also love incense. Indeed, my incense models will probably continue like this for a while. This is also very nice. The smoke pouring out of the dragon's mouth is spilling onto the stone in front of it and then down from there. It creates quite a beautiful visual. As for the printing quality, there's nothing to say. I mean, there's nothing negative. The surfaces are very nice. There is almost no distortion at right angles. Sharp points are very clear and there is no stringing. In my opinion, this model device clearly shows its compatibility with its own material. When we say standard Creality printing settings plus what we call Hyper PLA, the result is very good. Besides speed tests, the latest thing I got was a PLA print. Later, I also got prints with ABS and ASA filaments. Since it's a closed case printer, it should be able to process these materials. What you see is a printing taken with ABS, a filament holder with a stand. Not only in K1C, these kind of printings work in many printers. The fact that both the test model of K1C and this printing I got have a filament holder was something I noticed later, but it doesn't matter. Let's examine the printing examples. I didn't apply glue to the plate in this printing, and although it doesn't affect the purpose of use, there were small lifts slightly from the corners. The overall surface quality is quite successful. I don't see a problem with the layers. Since the cylinder part is smaller and circular, there has been no lifting in this. The surface quality also looks absolutely flawless. Indeed, of course, it says this on the plate for PLA. In my view, if you frequently work with materials like ASA, ABS, you may prefer these PEI-coated bill plate with a slight texture on top. It can make sticking to the plate easier. Alternatively, you can use various adhesive materials on this plate. For example, I applied stick glue while printing with ASA. You can also use this kind of glue. You can certainly use hairspray. You may also prefer utilizing special plate adhesive products produced by various brands for 3D printers. As I mentioned, I utilized Giotto Stick brand adhesive stick when I was printing with ASA. I'm satisfied with the result. Even though ASA is a difficult material to stick, I didn't have any problems. ASA is a very durable material against UV rays and humidity. Therefore, it is suitable for plastic materials to be used outdoors. This is also an outdoor security camera protective device. Let's look at the printing quality. I don't see any problems in the layers. The print I got at 0.2 mm layer quality came out quite smooth. We can't run the cooling fans when working with ABS and ASA materials, or we can only open the small fan between 10–20% at most. Therefore, there can be problems at right angles. There is a bit of sagging where this printing makes a right angle at its highest point. If I had provided support, this sagging would have been much less. Apart from that, we can see that the nozzle marks are a bit noticeable on its upper surface, even though it's not a big problem. Let's look at the TPU printings. The extra structure of K1C is very suitable for TPU. I got 2 printings. The designer shared this as a TPU test printing. It has no function. The surface quality is quite nice. I don't see a problem. Looking at its top surface, it came out quite smooth, unlike previous printings. This printing is also a toy. There is not the slightest flaw on it. The layers are spread out quite smoothly. Sharp protrusions are where stringing is most likely to occur. Perhaps TPU is the type of filament that frays the most. There's a bit of fraying between its ears, but it's minimal. It can also be easily cleaned. I definitely need to give this warning for K1C in your TPU prints. TPU filament sticks to the table too much. So this is now beyond a good degree of adhesion. I had quite a hard time while removing these printings. First, I carefully lifted the corner slightly with a utility knife. Then I gently elevated it with a plastic spatula. Let me show you how much it sticks using this rabbit model. The part you see stuck to the build plate so much that it separated from a piece of material. I will return to the textured PEI plate again. TPU is easier to remove from those types of build plate when the model cools down. Keep this in mind for those who will use this material. Now, since this device is K1 carbon, I would say let's leave the evaluation of carbon printings to the end. Let's have a change. This time, let's include speed tests. I worked on the same model again with speeds of 50, 150, 300, and 600 millimeters per second. I increased acceleration in proportion to speeds. Bus model you see consists of 2 parts. Now let's put them all side by side and look at differences. Let's start with the rule first. It's a simple piece, not much detail on it at all. I don't really see any changes at the edges or at the sharpest point on top. Everything looks the same, only as the speed increases, the layer lines have become more pronounced. When we look at the body part, there is no problem in general or in fine details. There are slight lines on the belt around its waist, but there is no serious increase due to speed. The smooth details on your clothes are definitely the same. I can't say there's a loss of detail in the accessories hanging from your hair either. As the speed increases, the lines have increased at 150 and 600 millimeters, but it's interesting. I had experienced this in K1 Max as well. It could be K1, I'm not sure. In my opinion, the best surface occurred at a speed of 300 millimeters per second. This was a detail that surprised me. There is a small gap at the top over 300 millimeters per second. We can see this again at 150 and 600 speeds. There is no such thing as 50. Maybe if I increase the printing temperature or the filling, this problem might not have occurred at high speeds. I don't see any problem with the jewelry part on her neck right away. The details have come out clear and beautiful in every model. Now let's take a look at the face part too. But before that, I indeed want to point out something. Possibly when you compare it with previous printings in your mind, you might think that the layer traces are more prominent here. They weren't that prominent in others. You're right, this is actually related to the angle at which the printing was taken, so it didn't take the printing of this bust in such a steep way. Because it is slightly angled, the layer traces become more pronounced. I wanted to share that information briefly from time to time, so you don't have a question mark in your mind. In my opinion, when we look at the facial details at different speeds, 300 millimeters per second is quite good here again. It definitely looks as beautiful as a model printed at almost 50 millimeters per second. I think the effects of vibration are more pronounced at 150 and 600. I think one of the important points is these earrings. There are very thin pieces rising there and independent from the main piece. If there was even a problem during printing on these thin parts, or if there was even a slight friction in the nozzle, the parts could break. However, it has come out quite clearly at all speeds. The printings are decent. It seems like the ideal printing speed of this device is around 200–300 millimeter per second. So those speed and acceleration settings we see when we open Creality Print are not made arbitrarily. Of course, we should not overlook the ratio of surface quality to printing time. We're talking about a printing time that drops from almost 9.5 hours to 4 hours. The speed has more than twice the positive effect on time. When I do such speed tests, I keep all the settings the same. So inner wall, outer wall, infill, and all increase equally. But generally speaking, I mean, perhaps no user genuinely prefers these kinds of settings, do they? So the points where you will use the speed can be on the inner walls, or you can give a bit faster printing while making the inner filling, and you can slow down the speed on the outer walls to increase the quality. It's possible to get much higher quality prints with these kinds of combinations, than what you see here. And here we are with the studies I've done with carbon fiber additive filaments. I worked on carbon fiber additive PLA and PETG. This additive material can be integrated into almost every type of flame, and generally we can say that it gives strength and hardness to the material. We can't process this with the standard copper nozzles I usually use because it's a very hard additive material. Because carbon fiber erodes this nozzle in a very short time, deteriorations start in the diameter of the nozzle and in its inner structure. That's why the developed nozzle we first saw exists. With its copper part, it transmits heat much better, and because the steel tip does not wear out, it allows us to easily process filaments with carbon fiber additives. At this point, I wanted to go through a line of work that requires endurance to get functional printings. Both production and post-production in furniture works use various sturdy tools and other accessories. For example, I printed a furniture leg and a vise with PETG carbon fiber. The vise consisted of 3 parts. As you know, it's a tool used for compressing things and it needs to be durable. I achieved a matte and very beautiful surface. There is absolutely no flaw on it. The gears and the parts that need to move are also moving perfectly and smoothly without any issues. The top surface is indeed quite smooth. There doesn't seem to be any nozzle marks. This is a furniture leg. The designer designed this as a monitor stand leg, so the dimensions are according to that, but by scaling it can even be used in furniture like stands, tables. It's a very clean printing. The layers are spread evenly. No problems are noticeable. In my opinion, the presence of organic lines also enhances its appeal. There is no smooth nozzle trace on the upper surface. There are perpendicular joints in the model printed without support. There is no sagging in these parts. This is a kind of vise. The printing I got with carbon fiber reinforced PLA. I got 2 different printing sizes. The designer thought very well indeed. You can strengthen by adding as many rubber bands as you need for a very strong compression. I also got prints in different sizes thinking it would be useful somewhere. I said let it be in the toolbox. Let me show you the other PLA carbon fiber printing as well. The models are different, but I will say similar things for both. This is a device that definitely comes in handy when gluing the corner joints of furniture. As you can see right now, the surfaces have printing very well. It's as if there are no layer traces. Despite being printed with 0.2 mm layer quality, it looks even more quality than 0.1 mm. Rest assured, what I'm saying is not an exaggeration. The top surfaces are quite smooth and no nozzle marks are visible. I can honestly say that I understood why the system was changed for carbon after I got these printings. Because in my opinion, the carbon fiber printings were the most advanced among the printings I received. One of the points that caught my attention apart from the printing quality of the device was its fan. As someone used to K1 and K1 Max's loud fan, it seemed quiet when I first turned on the device and the fans began working. I wondered if this larger fan wasn't working. I looked and it was working. Don't get me wrong, I'm not saying it's a very quiet printer anyway. I'll show it in the sound test soon. But there's a notable drop in sound compared to K1 and K1 Max. From the outside, the fan system looks the same, yet this is quieter. I achieved a result between 60-62 decibels in the tests I conducted with the standard Creality printing settings I just showed you, with cooling fans and covers open. In prints where we will not use a cooling fan like ABS, the sound dropped to the range of 50-52 decibels when the cooling fans and covers were closed. So the K1C is a loud printer when the cooling fans are on and a quiet one when off. There's no change in print quality per K1. Equivalent quality prints can be obtained with both printers. But as I just mentioned, I can say that I found the prints obtained with carbon fiber added filaments even more successful than PLA. This, of course, is a situation related to the printing settings and the quality of the filament you use. Still, it would have been much better if a feature that could elevate the printing quality a notch could have been integrated while such a different model was emerging. The leveling of the plate worked well in this series. The same goes for K1C. Giving the printing, it doesn't let us look back. The first layer is being laid at the right level. The era of manual leveling is over. I don't think we will see a manually adjustable bed from Creality anymore. In sum, a nice printer. There isn't a big change compared to the previous series. Apart from this nozzle system, we see some minor changes. In my opinion, these are more or less but useful changes. Creality is already aware of this, so I can say that the price difference between K1 and K1C is as much as the features changed. Surely some of you will ask this, therefore I can answer it now. K1 or K1C? If the difference won't strain your budget, go for K1C. But I'm already working with PLA, PETG, ABS. If you say you're not considering carbon printing, of course K1 is still a preferable printer. That's all I have to say about my K1C and the examples I will show you. I hope it has been a useful video for you and I have been able to help you make a decision. If you want to buy one K1C, I add the link to the Creality shop in the description section of the video. You can shop here. So, how did you find the printer? I would appreciate it if you could leave your comments about both the video and the printer below. May your printer work flawlessly, your printings be perfect. See you in the next video. Goodbye.